The behavior of polynomials at x-intercepts are determined by the zeros and their multiplicities of our polynomial. First, let's remember that polynomials can always be completely factored, though some of the factors may contain complex numbers. And each factor corresponds to a zero of the polynomial, and the power of each factor is the multiplicity of the corresponding zero. If our polynomial f of x contains a zero of even multiplicity, then the corresponding x-intercept touches but does not cross the x-axis. Here's an example of a polynomial that contains two x-intercepts that correspond to zeros of even multiplicity. Notice here the two zeros of our polynomial are corresponding to x-intercepts, and again, since our graph only touches the x-axis, both of these zeros have an even degree. Now, if f of x contains a zero of odd multiplicity, then f of x crosses at the x-intercept. Now, here's an example of a polynomial that has three zeros, each of which have odd multiplicity. Again, at each of these x-intercepts that correspond to the three zeros, we have our graph crosses, and so each of the zeros will have odd multiplicity. Let's go ahead and sketch the graph of this polynomial. To do this, let's find the y-intercept and the x-intercepts first. To find the y-intercept, we plug in x is equal to 0. F evaluate at 0 then will give us -3 times 0 times 0 plus 2 times 0 minus 4 raised to the third, and this is all equal to 0. So we'll have our y-intercept at the point 0, 0, and now we need to find our x-intercepts. Again, since our polynomial is given to us in factored form, we can go ahead and set each of the terms equal to 0. Our first term will get 0 is equal to a -3x. Our second term will get 0 is equal to x plus 2. And our third equation will get 0 is equal to an x minus 4 raised to the third. In this first case, we get x is equal to 0. In the second case, we get x is equal to a -2. And in this third case, we get x will be equal to a positive 4. And now we can go ahead and list the multiplicities of these zeros. So the multiplicity of this first zero is a 1. The multiplicity of this second zero is also 1. And the multiplicity of our third zero is 3. Now we need to go ahead and find the end behavior of our polynomial, and to do that we need to find the leading term of our polynomial. So to find the leading term, we need to factor out this polynomial, but not the whole thing. We can multiply -3x by the x here, and then also if we cube this piece here, we'll get some trinomial, but we're really only looking for this x cubed term here. So what we want to do is we want to multiply our -3x squared times our x cubed, and this will give us our leading term, which will be a -3x to the fifth. So let's go ahead and draw a picture of everything we have so far. The leading term tells us that the end of our graph is going to look like this. We'll have an x-intercept at -2, another one at 0, and then one at 4. And then our graph is going to cross at -1, then it's going to cross again at 2. Sorry, this was a -2 here, not a -1. And this is a 0 here. And then finally, it's going to cross again at 4. So we can fill in the details of our graph as such. So our graph will look something like this here. And this is the sketch of our graph. And so we're done. We'll now summarize how to sketch a graph of a polynomial. First thing, we want to find our x and y intercepts. Once we have our x and y intercepts, go ahead and find the multiplicity of the corresponding zeros of our x-intercepts. Then find the leading term of the polynomial. In step 4, we sketch out the end behavior. Then we use the multiplicity of the zeros to see how the graph acts at our x-intercepts.